Let's now turn our attention to how we name derivatives and isomers of alkynes. So again, we're going to start with the simplest alkyne, acetylene or ethyne, and we're going to substitute one of the hydrogens. Obviously, the two hydrogens are equivalent, so I could substitute either one of them for some substituent X. And I call these types of derivatives ethynyl compounds, or acetylyl compounds. So for example, I can have bromine coming off of the acetylene, and I can call this ethynyl bromide. Now, generally speaking, we um, actually call the bromine as, we can name the bromine as a substituent, and so this would be bromoacetylene or bromoethine. Um, any three of those names are correct way of naming bromoacetylene. And of course, if I take X and I substitute it with, if X is a methyl group, now I've extended my carbon chain and I get propyne. And of course, with propyne, now I have two different types of hydrogens. I have hydrogen A and hydrogen B. So if I replace hydrogen A with some substituent X, then I get what are called 1-propynyl compounds. 1-propynyl compounds, because I'm naming that one, the alkyne carbon, number 1. So, you know, the naming basically follows suit with the naming of alkenes. And of course, if I replace HB, then I get an X on one of the on the methyl group coming off of an alkyne. Now, these are called 3-propynyl compounds. But if you look closely, this kind of resembles characteristics of an alkene. Remember when I had a methyl group coming off of ethylene, if I had propene, and I changed, I substituted one of the hydrogens of the methyl group with X, then I had an allele compound. Likewise, with alkynes, I have that same effect. When I am substituting a carbon that's connected to that triple bond, it takes on its own name. But instead of an allele compound, I get what's called a propargyl compound, so propargyl bromide, propargyl alcohol, right? Now, in terms of, in general, naming alkynes, well, the rules are very similar to that of alkenes. So the key is to keep the triple bond number, the location, as low as possible. And if you have an alkene and an alkyne, so a double and a triple bond in a particular molecule, these are called ene-ynes. Ene-ynes contain both double and triple bonds. Now, what happens if you have a situation, a numbering situation, where you have both a double bond and a triple bond, and in one direction the double bond gets the lowest location, and in the other numbering scheme the triple bond gets the lowest numbering scheme? Well, it happens that alkenes, the double bond, beats out the triple bond if there is a tie in the direction of the numbering system. And we'll look at an example of this. So first off, how do you draw alkynes? Remember, alkynes are linear, and so we have to draw them as such. And here's an example. Now, let's say I have 3 carbons, but on the third carbon, that third carbon has a triple bond to a fourth carbon. How do I draw that? Well, I draw it in a straight line, and to denote that linearity. And so these are typically the bond line formulas of alkynes, where the triple bond has that linear configuration. when we number, then we have to remember that, there's 1, 2, 3, 4 carbons there. So for a 4-carbon chain, that's the base name's butane. It's an alkyne, so we're going to change butane to butyne. The triple bond is between the 1 and 2 carbons, so we're going to name this 1-butyne. Keeping in mind, right, it's a linear structure, so we can incorporate the geometry of alkynes into our bond line formulas, which is one of the reasons why we like to use bond line formulas. And I'll show you another example. So here, how many carbons do we have? I'm drawing that straight chain, and sometimes students get a little confused about how to number this. So I'm going to take a moment and see if you can figure out how many carbons there are. If you said 6, you are correct. Now, there are 6 carbons. When I number this chain, notice if I start on the left-hand side, 1, 2, so 2 would be the lowest location. If I start on the right side, 1, 2, again, 2 would be the lowest location. So which direction do I choose? Remember, alkenes beat out alkynes, and therefore I number this from the right 1, 2, 3, 4, 5, 6. So the alkene's on carbon number 2, the alkyne is on carbon number 4. Now I've also showed some stereochemistry of the alkene. Notice alkynes don't have any stereochemistry since they are always linear. Alkenes do, though. The hydrogens are on opposite sides, so that is E, and therefore we get E, 2-hexene, 4-yne. It's an ene-yne. Notice the way that I have to give the locants. I have to basically separate the ene-yne, and in between I put the location of the alkyne. So I first put the location of the alkene and then the location of the alkyne. Another example here is an alkyne. It has alkyl groups coming off of it. Again, I'm going to start numbering, giving the alkyne the lowest location possible. So I number this 1, 2, 3, 4, 5, and therefore there are 2 methyl groups on the 4-carbon. This becomes 4,4-dimethyl, 1-pentyne. Oh, that should be pentyne, not pentene. Another example is here I have a ring. Now, when you have a ring and you have an alkyne coming off of the ring, there's actually a few ways that you could name this. So you could name this as a derivative of acetylene, and that would be a cyclopentyl derivative of acetylene. So you would name this cyclopentyl acetylene. But remember, acetylene's a common name. Ethyne is the IUPAC name, and therefore you could name this cyclopentyl ethyne. And both of those are acceptable names. Now, on the other hand, you could name the alkyne as a substituent of the ring. And if that was the case, you would get ethynyl cyclopentane. All 3 of these names are acceptable names in naming this particular structure. Another example where you have this ring is here I have cyclohexane. In this example, if you look closely, you have that propargyl substituent, and therefore I could name that group coming off of the cyclohexane ring, and this would be propargyl cyclohexane. Propargyl cyclohexane. Likewise, I could name the cyclohexyl group coming off of that chain that contains the alkyne. So that's a 3-carbon chain, so it'd be propyne. And the cyclohexane ring is coming off of the 3rd carbon, and therefore this would be 3-cyclohexyl, 1-propyne. Again, 2 names, they both are acceptable in the realm of naming this particular compound.